Let's talk about solid design principles in this video. So if you're in software engineering field for a while, you already may have heard about it. If you haven't, don't worry, I will try to make it very easy for you. So basically what I'm going to talk about today is that the definition of solid principles in software development, so the background of solid principles briefly, and the motivation behind um, coming up with these design principles or solid principles in general, and we'll go over the each of these solid principles one by one with example. And finally I will briefly discuss about the other principles that are there beyond solid principles. Okay, so let's get started. So in software engineering, solid refers to the five design principles which uh, are there to make software designs more understandable, flexible, and maintainable, which means that these principles are used in software development in order to make that software more maintainable and make the software code more usable. And using these principles, the developers or the software programmers could provide sustainability to their software. So that is basically the brief definition of these principles. So what is the background? So basically these principles were introduced by Robert C. Martin in his year 2000 paper, Design Principles and Design Patterns. And later on, another guy named Michael Feeders actually introduced us to this term solid. So back then, before that, there was no term called solid. So this is basically the background of the solid principles. And what was the motivation behind introducing these principles actually? So back in those days, code management was very difficult. Okay, so most of the software were monolithic, and um, as the term suggests, like if there is any bug or issue arises, then it became the nightmare for the whole organization, not only for the developers. Okay, so it was very difficult to maintain the code, and there was poor dependency management, so which led to uh, non-flexible, fragile, and non-reusable code, which means that code were very hard to change, code were uh, the software which made the software very fragile, very prone to errors, and if any issues or any bug came up, those were very hard to fix, and the code became non-reusable. Okay, so these sort of things made pioneers like Robert C. Martin or some other prominent software developers to come up and rethink about the um, implementation of a software. Okay, so they gave a thought and found out that there is better approach than this way, and then they came up with different object-oriented design and design patterns, design principles. So this is how we are here today, and having great object-oriented system, object-oriented software all around us. Okay, so let's get started with the solid principles. Okay, so first I want to talk about the single responsibility principle, or SRP. So this is basically the um, talks about a class which should have only one responsibility rather than many responsibilities in one single class. Okay, so it also um, emphasizes that one class only have one reason to change. So what it basically says is that one class, one functionality. This is the basic term I could use to make you understand what is solid responsibility principle. Okay, so what are the benefits? So if one class has one single responsibility, it means that the code is clean, or it suggests that the code is going to be clean enough since there are uh, only one functionality implemented in one single class, which means that less dependency in that class, and which leads to lower coupling. And finally, the testing becomes much easier when you know that the functionality your class offers. You do not have to think about the other functionality during writing your test cases. So eventually testing becomes much easier. So now let's take a look at an example. So here is one class we have, that is the search class, which has two methods. One is the apart from the constructor, obviously. One is the find data, which offers the searching of a data in the data list. Another one is the sort data, which uh, sorts out the data list. So what's the problem here? What's the problem here? So what I would say is that the ambiguity is the first problem. That is, the class name is search, which means that this class should offer anything related to search. But instead, it's also offering something called sort data, which is definitely violating the SRP, or single responsibility principle. Okay, so instead of implementing the sort data in this class, in this search class, what we could do is we could just taking out that sort data function and putting it into another class called sort. So now this both class look this way. Search has one function or one method, that is find data, which searches data, and another one is sort data from in the sort class, which offers the sorting of the data. So this could be an example of SRP. Okay, so that is it. That is all about the single responsibility principle. So now let's talk about the open close principle. So this principle actually refers to the extension of a class instead of modifying it, because when you are working on a legacy code, there is a chance that a bug may occur or issues may come up, which can destabilize the whole system if there is much more dependency in that class. Probably this could lead to major issues, and eventually the whole software may become non-functional. So as you may have understood already, what I'm saying is that our classes should be open for extension but closed for modification. Okay, so by doing so, actually we can save ourselves from generating more bugs and issues in software development, or something like a big software project. Okay, so let's consider a scenario here. So let's say we want to display the sorted data list. Okay, so we have one class, sort class, which has a method called sort data, which sorts out the data from the data list. So what we could do, instead of writing that display sorted data in that class, in that particular class, we are creating another class which is the display sorted, which is basically extending the sort class. That is, it's not modifying it, it's extending it. It's working as the extension to the sort class. Okay, so as you can see, this display sorted method actually using that sort data function from the sort superclass. So this is the basic example of open close principle. So yeah, And then we have the Liskov substitute principle. So this is very simple, but try to make it simpler. Okay, much more easier. Okay, so what is it? Is that if you have a subclass to a parent class, the implement the subclass in a way that the parent class can be replaced by the subclass. Okay, so basically is that parent class can be replaceable by the child class. So this is what the substitute principle suggests. Okay, so if we take an example, is that let's take the same example as we have discussed in the open close principle. So we have one sort class here which has a function sort data, and we have the display sorted class which actually is um, offering the display sorted data. So this is basically B class is actually not violating any features or any functionality of sort. Instead, it's extending it and using the sort functionality itself. So it can be replaced by, so the sort class can be replaced by display sorted class eventually, maybe with a little tweak. But what I'm saying is that B A class is replaceable by class B here. Okay, so this is basically what Liskov substitute principle talks about. Okay. Okay, so now let's talk about the fourth one, which is interface segregation principle. So what happens is that if we have one interface and which is quite large, which has so many functions um, offered by this interface, then the problem happens when the implementation class actually is not interested to some of its functions. Okay, so even though it's not interested, the implementing class still should be implementing those for at least keep them in that class. So what happens is that it leads to uh, I'll say code um, uh, less code clean. I mean, it makes the code looks uglier and unnecessary implementation blocks in an implementing class. So that happens uh, when we have a larger interface. So this interface segregation principle addresses that issue and um, offers a solution to it. So let's consider one operation interface here which has two functions, search and sort. And what happens is that when search class implements this operation uh, interface, and also the sort class implements this operation interface, so both have to implement both the functions from that operation interface, so which leads to redundancy, code redundancy. As you can see, this search class will still have to put keep this sort function in it, and same goes for the sort class, which has to keep this search function in this class as well. So how we can solve it, instead of putting both these functions in the same interface, we could instead create two separate interfaces and put search function, define search function in search operation interface, and sort function in sort operation interface. So which could specify which class is interested in which interface. For example, search is interested in search operation interface, which only implements the search function, and same goes for the sort class, which implements the sort operation interface, which also only needs to implement the sort function as well. So that's clean coding. And now finally, we have come to the dependency inversion principle. which is a little bit interesting. So let's try to make it simple. So it has two laws. One is the high level module should not depend on low level modules, and both should depend on abstractions. And the second law is abstraction should not depend on details, rather details should depend on abstractions. So what does this means? Let's take an example which could which would make it much more easier to understand. Okay, so let's take at this code. Um, so let's say we have operation class which wants to execute both search operation and sort operation in it. So for doing this, it declares two variables. One is the data list, another one is the data, and passes these through the constructor. And um, execute search operation actually creates a new instance of search class and passes these two variables as the parameter, as the required parameter to execute the search operation. And also the same goes for the sort uh, operation function, execute sort operation function, which is it creates a new instance of sort class and passes out the required parameter and execute the search operation, sort operation, sorry. So what's the problems here? Can you figure it out? Yes, the operation class actually needs to know much about these implementation classes. Okay, so operation class needs to know too much about the implementation details. Okay, for example, it needs to know how many parameters the search and the sort functions needed, and their data types as well. So it's much more like abstraction is violated here. Okay, and also if you need to make any changes in your search or sort class, for example, you do not want to provide two parameters, instead you want to provide one parameter for search class, so you need to make that change here as well. So this is basically the violation of DIP, or dependency inversion principle. So if you it's much easier, okay, to understand what I'm saying. So you could argue that, hey, instead of doing that way, we could actually parameterize both these functions, and instead of variables, we could probably pass the class object, which could literally call the function from the class, search and sort. So it actually doesn't work this way. I mean, it works. I mean, it gives you the output, proper output in both these examples. This will also give you proper output. This will also give you proper output. But like the previous one, this one also violates the second law. I mean, it it still needs to depend on the implementation details of the search and sort implementations, rather than the abstraction. Is still not depending on the abstraction, rather depending on the low level or the implementation level details. Okay, so this is also a violation of dependency inversion principle. So how this could be solved? Now take a look at this. So instead of the class, we could use the interface object. Okay, so or yeah, so what happens is that this operation actually does not know anything about the implementation details at all. It's depending on the abstraction for both search and the sort. So it's ensuring that if there is any changes in the search, this operation class is oblivious to that change. It has nothing to do with that change. It depending on this search operation interface or abstraction. Okay, so as you can see in this picture, that this search operation and sort operation is providing that abstraction. Okay, so this implementation classes also depend on that. That means the low level components are depending on that abstraction, and the high level also depending on that abstraction. And through this abstraction, they are actually interacting with this with each other. Okay, so operation class actually using this abstraction to communicate with this search and sort. Okay, so this is basically what dependency inversion principle talks about. So that is basically all about the solid principles, and beyond that we have a few more. For example, I mean, solid principles basically talk about the class level design, and the other the remaining remaining principle design principles talk about the package level design. For example, these three here, rep, ccp, and crp, these talk about the package cohesion. For example, the rep talk about the granularity of reuse is the granular of release. That means that if you are willing to use a some feature, some component of the current release in the next release, so you have to uh, make it clear that you have to version control your code. Okay, version control means there should be some release uh, uh, tagging or versioning in your code, in your packages, so that you can identify which version, which release this component is actually coming from. So this provides much more granularity in your code. So what about the cpp and crp? So these are ccp, crp is basically the classes which are actually interacting with each other should be put together in the same package. What I mean by that is, if multiple classes have dependencies within each other, rather than taking them into several other packages, put them in a same package. This is basically the CRP, the common reuse principle. So what about the CCP? So if there are classes that are actually changed together, should be packaged together as well. So what it means by that is that one package should have only one reason to change. Okay, so this is basically so okay, so that's the CCP, common closure principle. And what about the other three? Okay, so the remaining three principles basically emphasize on the couplings between packages. Okay, so for example, ADP, the acyclic dependencies principle. So that is basically we what it refers to is that do not create cyclic dependency between packages, which is also ensuring that the if your code is acyclic dependent, that means that your code does not have any monolithic nature within themselves. The packages do not uh, have the cyclic dependencies, so there should be acyclic dependencies. Okay, so this ADP refers to that one. So what about the stable dependencies principle? So yeah, this is the interesting one. So if, for example, um, one package have multiple other dependent packages, but this package, the package which is dependent by others, is frequently changed, frequently updated, which is not stable, may lead to major problem for large software, because if this some code from this package changes, then the dependent packages also need to be updated as well. So this may lead to major problem down the line. So if there is one stable package, make the dependent package or the package which are dependent on, make more stable, so that there is less changes. So this SDP actually talks about it. And the final one is the SAP, the stable abstractions principle. So this is basically the same thing. It also emphasizes the abstraction of packages. So instead of like um, depending on each other too much, depending on knowing about each other's details, uh, make it abstract. Okay, so that is basically it. Thank you so much for watching. So if I have uh, enough opportunity in the next time, so I will go over this with example. So thank you so much for watching. Peace out.